Hi guys, in this video I'm gonna talk about derivatives of some inverse trigonometric functions. We first consider trigonometric function sine, which is 1 to 1 and onto. It means that it has inverse function and we have this inverse property. Sine composite arc sine x is x. Similarly, arc sine composite sine x is x. And we also know that y is sine x, derivatives of y with respect to x dy over dx is cosine x. So what about derivative of arc sine x? To compute derivative of arc sine x, we first apply trigonometric function sine to both sides of this equality. Then we get this equality and we get this derivative function. Derivative of x with respect to y is cosine y. And we also have this triangle by using this equality. We have some angle y at which sine takes x value. Then we get cosine y is square root 1 minus x squared. So to compute dy over dx, we first write this derivative as 1 over dx over dy. By substituting this equality and this equality into this expression, we obtain derivative of arc sine x as 1 over square root 1 minus x squared. We can extend this special case to more general one. Consider this composition. Derivative of this composition can be obtained as u prime over u prime of x over square root 1 minus u squared by chain rule. So consider this example. Derivative of this function is 2x plus 1, which is derivative of this expression, over square root 1 minus u squared. Next inverse trigonometric function, y is arc cosine x. When you apply trigonometric function cosine to both sides of this equality, we obtain this equality. Then we get this derivative function. Derivation of x with respect to y is minus sine y. So by using this triangle, so we can get that sine y is square root 1 minus x squared. Substituting this into this expression, we shall get this equality. Now again, we write dy over dx in terms of dx over dy. By substituting this equality into this expression, we shall get derivative of arc cosine x as minus 1 over square root 1 minus x squared. Again, we can generalize this situation to more general one. Consider this composition. Derivative of this composition with respect to x is minus u prime of x over square root 1 minus u squared. Now we consider inverse trigonometric function y equals the arc tangent x. When you apply trigonometric function tangent to both sides of this equality, we shall get this equality. Again, we derivate x with respect to y, we get this expression 1 plus x squared. dy over dx can be written in terms of dx over dy in this form. And when you substitute this expression into this expression, we shall get derivative of arc tangent x. So again, we can extend this situation to more general one. Derivation of this composition is u prime of x over 1 plus u squared. Similarly, we can obtain derivative of arc cotangent u of x as minus u prime of x over 1 plus u squared.